Welcome to the Pixl Maths Walking Talking Mock. This is the Edexcel style higher paper 1. A scatter graph shows some information about 10 cars. It shows the time in seconds, which we can see down here on the x-axis. It takes for a car to go from 0 to 60. For each car, it also shows the maximum speed here. So before we start looking at the questions, let's take a look at the scale here. We're going from 8 to 9, so we're going full seconds up here. So halfway will be 8.5 seconds. Up here, we're looking at our speed and we're going from 100 to 110. So each one of these squares is worth 1 miles per hour. It's always worth taking a look at the scale before starting a question. We're first asked to write down the type of correlation. So here we can put positive, negative, or 0. Here we can see the points are going down. So as the speed decreases, the number of seconds is increasing here. So here we have a negative correlation. If our scatter graph points are going downhill, it's negative. In the opposite direction, we have positive correlation. For 2 marks, we're asked here now the time taken for the time taken a car takes to go from 0 to 60 is 11 seconds. So finding 11 here, we then need to estimate the maximum speed for this car. You need to take your ruler out first and draw a straight line, a line of best fit. So going through roughly through the points, we need to have approximately the same number of points below the line as above the line. Maybe just moving it slightly that way. Here, we've got 1, 2, 3 below, 4 below, and 1, 2, 3 above, and a few points on the line. So now taking your ruler again, you need to go from your 11 on your x-axis all the way up to your line of best fit, and then across here to your y-axis to read off the maximum speed. Now this will vary depending exactly where you drew your line. For my graph shown here on the screen, my value is coming out as 1, 2, 1. However, in an exam, an examiner would accept any answer between 117 up to 123. So just make sure that your value for your line is coming somewhere between 117 and 123. Here is a list of ingredients to make scones for 4 people. We're asked for each ingredient to make it for 6 people. So there are a number of ways you might want to do this. I would suggest you first find it for 2, half everything. So we have 100, 1, 25 and 50. Then it's easy to find for 6 because we just add these together. 4 plus 2 makes for 6. So 200 plus 100, 300. 2 plus 1, 3. 50 plus 25, 75. And then for the milk, 150. This question is about transformations. First, you're given triangle T and told to reflect the triangle in the y-axis. The y-axis is here. So taking your ruler, your triangle is going to be here, across 2, up 3, and then connecting across here. We must label this triangle A as told to in the question. Then have to rotate the triangle T, so this is back to our original triangle, by half a turn, 180 degrees, center 0, here, that's where you're going to put your point, your pencil point, as you turn. Use these things to take some tracing paper. Trace over T, then put a sharp point to your pencil here, and then turn. You're going to turn it once to 90, which will lead your triangle here. I'll just do a quick sketch of it. That's to 90. Turning it again, you're going to have your triangle down here across here and connecting. Label this new triangle B. So reminder, this would be 90 degrees, this here is 180 degrees. We then have here an enlargement. You can see immediately that C is an enlargement here of T. There's 3 marks available. You've got to say 3 things. So first mark is from enlargement. Second mark is by saying the scale factor. How many times bigger is this triangle? Well, let's take a look. The base here is 2, and here we have 6. The height here is 3. Counting along here, we have a height of 9. So in this case, the number we have multiplied to get from 2 to 6 and from 3 to 9 is 3. So the scale factor is 3. Lastly, we must find the centre of enlargement for the third mark. To do this, you need to take your ruler and connect corresponding points. So this point corresponds with here. The corner point corresponds with here. And then lastly, here corresponding with here. So taking your ruler, you're going to draw the lines backwards until they meet. So this one with this one, overextend all the way through the axis, here and here. And just for good measure, check with the last one. And you can see that the centre, where all the points are converging, meeting, is here. So that our coordinate here is 0, 0. We're told that 36 students each went to 1 revision class. 6 of these went to physics, 2 ninths went to biology, and all the other students were at chemistry. We need to know how many were at the chemistry. So let's take a look first. 1/6 of the 36. So 36 divided by 6 is 6. So for physics, we had 6. Biology, we're going to split our number 36 into 9. 36 divided by 9 is 4, but that's 1/9. Times it by 2 gives us the number for biology, 2/9, which is 8. And all the other students went to chemistry. So adding our physics and our biology, we have 14 students. 36, subtract 14, leaves us with 22 students who must have been at chemistry if they were not at physics or biology. Fred is going to take a survey of magazines read by students. In the first part, we're asked to assign a suitable question he could use to find out what type of magazines students read. So here we need a simple question such as, what type of magazines do you read? So simple question, finding out what type of magazines do you read. But importantly now, you need to give them some options. So picking some types, for example, sports, TV magazine, politics, gardening, any magazine you can think of that gives an option, and importantly, a final box of other. So 3 or 4 choices and then an other box, or indeed none if they don't read magazines. Fred put the question below, how many magazines have you read? And the options, a few and a lot. Now this is not a very good question. We're asked to assign a better question and some better response boxes. The really important part about this question is to have a time frame. So this question needs to change to how many magazines have you read in the last, insert something, week, month, year. Really important, it must have a time frame. For some options here, we could have 0 magazines, We could have 1 to 2 magazines, 3 to 4, important these do not overlap, and then possibly 5 or more. So this is a lot clearer than saying a few or a lot, because this might mean different things to different people. Here we're told that CGEL says if A and B are prime numbers greater than 2, then A multiplied by B is always an odd number. Is CGEL correct? Give a reason for your answer. So first off, let's look at the prime numbers greater than 2. So we have 3, 5, 7, 9 is not a prime number, 11, 13, 17, 19. Probably won't need to go any further than that. So we need to say, if we multiply 2 numbers together, we are always going to get an odd number. You will notice that all of the primes are odd. So it doesn't matter which combination we take, we are always going to have an odd number because we're not using 2. So is she correct? Yes. Let's have a look. Take any 2 numbers. 3 times 5, 15. 7 times 11, 77. So the reasons for this, we have all primes are odd, except 2, but we can't use 2 because it says it's got to be greater than 2 here. And we can state that an odd number multiplied by another odd number always gives us an odd answer. So is CGEL correct? Yes, for these 2 reasons. Express 252 as a product, means multiply, of its prime factors. First step, let's just remember what the prime numbers are. First prime number is 2. 1 is not a prime number. This is special, it's the only even. 3, 5, 7, 9 is not a prime number. 11, 13, 17, 19. They're all the prime numbers under 20. So we're going to take 252 and we're going to split it. So there are many ways you can do this. 252 is an even number, so let's split it by 2. 2 is a prime, can't continue. Half of 152 is 126, also even number. Split it by 2, get 63. 63 is not an even number, can't divide by 2, but can divide by 3. 3 times 21 makes 63. 21 can also be split into 3. 3 times 7. 7 is also a prime number, so we have to stop there. But the last step, because it wants it as its product, we must do 2 times 2 times 3 times 3 times 7. We want to make that neater. 2 squared times 3 squared times by 7. So that is 252 expressed at its product, multiplications in between, of prime factors. A car sells British cars and foreign cars. We've got a ratio of British, B, to F, 2 to 7. We're told that a car sells 45 in 1 week. That is the total. But we want to know the number of British. So this B, what part is the 2? So this is sharing a ratio, an amount, into a given ratio. Step 1, add up the 2 parts of the ratio, 9 parts. Step 2, divide our total, 45, by the number of parts, which gives us the value of 1. But we need 2. So 5 times 2 gives us the total of 10 British cars. If it was foreign cars, we'd be doing 7 times 5, 35. But this is the answer they require here for this question. We then have a price of £80 plus VAT and asked to find the total. Now remember, we haven't got a calculator. The easiest way to do this is take our value for 100, which is the total amount, 80. Then find the value for 10. by dividing here by 10, dividing here by the same, 8. Then dividing by 2 to find 5%, then halving again, dividing by 2 to find 2.5% too, and then adding everything up to give us 17.5%, which is this bit, 8 plus 4 plus 2, which is 14, plus the 80, because we're adding it's £80 plus the 14, for our total price of the tyre as £94. Here we have a quadratic graph. We need to plot the values on our graph here, and then we're going to use our graph. So let's take a look here at the missing tables and the missing values in the table. We've got x being equal to -1. So we need to replace our x here with -1 and here with -1. So let's go nice and slowly. 2 bracket -1 close bracket squared, -4 bracket -1. You haven't got a calculator here, so use brackets, and we're not going to make any mistakes with our negatives. So first let's take a look at the power here. If -1 times -1 is +1. Remember, -1 times -1 is going to give us +1. So we have 1 multiplied by 2, gives our answer of 2. Looking here, we have -4 multiplied by -1. Similarly, negative and a negative is a positive. So our answer here is +4. 2 plus 4 gives us our answer of 6. So our missing value here is 6. Okay, less complicated now with our positive values, but still be careful with our -4 here in the middle. So replacing by 1, we'll have 2 times 1 squared minus 4 times 1. This part, 2, this part, 4, 2, take away 4, -2. My next here is 2. We have 2 times 2 squared. 2 squared is 4, 4 times 2 is 8. Minus 4 times 2. 4 times 2, 8, negative, positive, minus 8 gives us our value here of 0. You can see we've got a symmetrical pattern here with our 0 and our 6 going down here to -2. So plotting this now onto your graph, always use x as our first value. X is 2, y is 16. So x is -2, y is 16. So here. Then going across, -1 up to 6, 0, 0, 1 minus 2, it's just there, 2 is 0, and 3 here back up to 6. So we've got our U-shaped curve round here. Be really careful here that we don't have the situation where we've got a point. It needs to have a smooth curve. Now you'll be able to draw a better one than I can on my computer screen here, but you're connecting your points in one smooth curve for the second point, down here to 0. Now remember what I said at this point here. You're going down, but don't, oh, that's a little bit too low. Don't make it too pointed. So nice and smooth curve round. Doing this with a pencil, you can always have a second chance rubbing out and having a go. So smooth U-shaped curve. We're asked then on the same axis to draw the line y equals 2.5. So taking your ruler, you're going to draw a straight horizontal line at 2.5. 1, 2.5 is this point here. Our line going across. Going to go through here. Now, there's a reason why we've been asked to draw this, because we can see here that they've put the two graphs equal to each other and then asked to find the values of x. So we can see here that they've put this equal to our equation. So we are looking at now the crossing points, where the two lines cross. So we have a point here and we have a point here. So reading down from our graph, we can see this point is at negative 0.5 a half. I'm reading across here approximately just there at 2.5. So our two values for x is minus 0.5 and positive 2.5. Here is shown a triangle with three angles in. The angles are expressed algebraically, but it means exactly the same thing. All the angles in a triangle add up to 180. So we're going to use this information to write a simple equation. 2x, this angle, plus x plus 18, this angle, plus 2x plus 7, the third angle, equals 180. Now we're going to need to use this equation to find the value of x, so we might as well simplify now. So first off, collecting all of our x's together, we've got 2x plus 1x plus 2x, which gives us 5x. Then looking at our values here for our numbers, we have positive 18, positive 17, positive 7, not 17, 7, so that gives us 25, equal to 180 degrees. So that's our equation. Now we're going to solve it. So first step, subtracting 25 from both sides is going to leave us with 5x equal to 155. Dividing through by 5, because we only want to find out what 1x is. 155 divided by 55 is equal to 31. So the value of x is 31. Here we have an inequality. Y is an integer, a whole number, not a decimal. Write down all the possible values for y. So the first part is to look at each side of the inequality. Minus 6, less than or equal to 2y. On the other side here, 2y less than 5. So here we have 2y, we want 1y. So dividing through by 2, we have that y is greater than or equal to negative 3. Similarly here on the other side, we only want 1y, so divide through by 2, y is less than 5 over 2. Also thinking about this, we can pop this being down as 2.5. Putting this together here, y in the middle, it's less than 2.5, remember it's got to be a whole number, but greater than or equal to negative 3. So all the possible values, it can be negative 3, it can be negative 2, it can be 1, negative 1, 0, 1 and 2. 2 is the highest it can be, so it's got to be less than 2.5 and it's a whole number. So here are the 6 possible values for y. Write down the size of the angle marked A. Here we have a set of parallel lines. When we have angles around parallel lines, this question is always about corresponding and alternate angles. Here we have a set of corresponding angles. The value of A is 45. We can see here that the shape we can make across the parallel lines is an F shape. And this tells us that this angle and this angle are equal. In mathematics, the reason we call these corresponding angles. And corresponding angles are equal. So the value for A is the same as the angle here, 45 degrees. In this question, we have some circle theorems, rules about circles. First, we're asked to find the angle CBA. CBA is this angle here at the circumference. One rule states that the angle at the circumference is angle at the circumference is half the angle at the circumference, or said in another way round, the angle at the centre is double, twice as big, angle at circumference. So here, the angle at the centre is 130, so the angle here at the circumference, angle here at the centre is 130, the angle here at the circumference will be half that, 65 degrees. In this diagram, we're showing the angle at the centre here to be 110. Therefore, this angle, half of that, will be 55. The angle at the centre is twice the angle at the circumference. We're not interested in that angle though, but this angle here that we've just found is going to help us find RSP. RSP. This angle here. This angle is not 55. This angle is part of the angles shown here in the cyclic quadrilateral. We can see here that RSPQ forms a quadrilateral where each of the corners, the vertices here, are on the circle. And the rule states that opposite angles in cyclic quadrilateral, a quadrilateral inside a circle, add up to 180. So to find our missing angle here, we are simply taking 180, subtract 55, 125. So our missing angle here for RSP is 125. Here we have a pair of simultaneous equations to solve. Our first step is to make one of the variables either x or y the same. Looking here, we can see here we have 4x and 2x. So we can simply multiply this through by 2, 4x minus 10y equals 20. So the multiplying by 2 here applies to this, this, and this, all three terms. We now have our 4x being here and here. So writing out our first equation here, we can put it underneath 4x plus 2y equals 8. So here we need to eliminate now the x. So by subtracting, we're going to remove here our x's. Careful here with our negatives. We have minus 10y minus positive 2y. So minus 10y minus positive 2y. Two signs together, one positive, one negative, going to be negative. So we're going to have minus 12y equals 12. 20 take away 8, 12. To find y, 12 divided by minus 12 gives us our value for y at minus 1. Once we have found the value of 1, in this case y we have found, we must substitute back into the original, not any of the ones that we have changed, such as here. So let's take our first equation. 4x plus 2y equals 8. We're now going to replace our y by minus 1. So we have 4x minus 2 equals 8. Here we have 2 times minus 1 for our 2y, giving us our negative 2 here. Solving by adding 2, we have 4x equals 10. So x equals 10 divided by 4, which is 2.5. So here we have now our second value that we're trying to find, x being equal to 2.5. The last step before you move on is to check that both of these values fit into the equation you haven't yet used. So let's take our second equation, 2x minus 5y equals 10. So 2 times 2.5 is 5. Minus 5 times minus 1 is positive 5, gives us our value of 10. So we know here our two values for x and y must be correct. Here we have an equation given to us and given two values for a and h. We need to find x. So the first step is to replace what we have here for the values. So 27 equals 4 bracket x plus 10, close bracket, all divided by 2. Now we're going to have to do some rearranging to be able to isolate the x. So first this says divide by 2. So we're going to times by 2. 54 equals 4 bracket x plus 10. Next step, expand the brackets by multiplying. 54 equals 4x plus 40. Finding our x on our own, subtract 40 from both sides. We have 14 equals 4x. We don't want to know what 4x is, we want to know what 1x is. So dividing through 14 divided by 4 is the same as 7 over 2. Half of 7 is equal to 3.5. So our value here for x is 3.5. This question is about cumulative frequency. We have an operator who takes 100 calls. First off, we need to do the cumulative frequency. The first value is 16. We then must add 34. 16 plus 34 is 50. Then we add 32. Plus 50 gives us 82. Then add our next value, 14 plus 52, 96. And our last value here of 4 gives us our total of 100. If our number here was different to that given in the question, we would have made a mistake along here with our cumulative frequency. Now plotting. Really important, onto your graph, you must be plotting the upper boundary here with your cumulative frequency, not the middle of the group. So our first value here is 10 and 16. Let's take a quick look across our axes. So we're going to be able to find these points easy, 10, 20, 30, 40 and 50. But if we go here to our y-axis, we can see that halfway here is 10. This means that each one of these is worth 2, 4, 6, 8, 10. Okay, so if we've got 10 here with our 16, our cumulative frequency, we're going to go here and then 2, 4, 6. So 16 is 3 spaces up from the 10. Our next is 20 and 50. 50 is going to be here, halfway between 40 and 60. We then have 30 and 82, up to 80 and one more square for 82. 40 and 96 is going to be 2 away from 100 here. And lastly 50, our frequency here of 100. For the next mark, we need to take our pencil and draw a smooth curve through these points. The shape needs to be an S-shaped curve, so it's going to come up and round. So right here from the origin, you'll be able to do a better job with your pencil on your paper. You're going to come under and then up. Try and make it one continuous, smooth curve. Through all the points, this is without a ruler, right up to the top here where it plateaus at the final value for 100. We're then going to use our graph. It makes it really clear by using the words in the question, use your graph to find an estimate for the number of calls you took. In bold, this must be important, more than 18 seconds. So first off, let's find 18. We've got 20 here, 10 here, 2 down. Remember, we're going up in ones. 18 seconds is here. So taking your ruler, at the 18, a straight line up to your curve. Going across to the y-axis to find the corresponding cumulative frequency. And here we have a value of 42. Now your value might be slightly different, but it needs to be near there, the 42. But we want to know how many take more than, so in this direction, how many more than. So we're going to take 100 as our total, subtract 42 to find out that there were 58, the frequency between the 42 upwards for the number of calls the operator took more than 18 seconds to answer. So that's really key there, that last bit. The answer is not 42, you're subtracting 42 from the total frequency, 100. Here we're given 5 equations of straight lines and asked to write down the letter of the line that's parallel, first off, to our equation here, y equals x plus 6. For a line to be parallel, it must have the same gradient. The gradient part is here. It's the number, the coefficient in front of x. So here we just have 1x, x. So we've got to find something that's got the same, -2, -half, half. So here we have the same part for x. Doesn't matter about 5 and the 6. The number in front here of the x. So that's our equation, letter R. So we can cross that one off, that won't be used again. Let's take a look now at the next one. We're asked to write down the letter of the line that's perpendicular. Okay, so perpendicular is also really important about gradients, and it's looking about this number here. For a line to be perpendicular, we call the gradient in one line n. A perpendicular will be the negative here reciprocal, -1 over the gradient. So here we have a gradient of 2. So here we are looking at 1 over 2. Again here, so we're looking for 1 over 2. It's going to be negative, the negative 1 here. So we're looking at s. So our equation here, the coefficient is -1 over 2. So corresponding with the letter S for this graph. We're then asked to find the coordinates of the point where the line y equals 2x plus 5 cuts the y-axis and then the x-axis. So if we look quickly at a graph, we've got our y-axis and our x-axis here. If a line is cutting the y-axis, the value for x will be 0. So let's substitute in the value for x being 0. So we have y equals 2 times 0, nothing, plus 5 is just 5. So our coordinates there are 0 and 5. Looking at now here where it crosses the x-axis. The x-axis is along here. Wherever it crosses, y is going to be equal to 0. So substituting in, 0 equals 2x plus 5. Solving for x, take away 5 from both sides. 2x is equal to -5. So x is equal to -5 over 2. Also -2.5. So our value for x will be -5 over 2. You could also write it as -2.5. And our y value here is 0. So these are the corresponding coordinates for where the line crosses the x-axis. Here we have an unfinished table and histogram, which shows information about the weight, here are grams of fish that Alan caught each day. So let me look here. We've got our scale and our label across here for our x-axis. We haven't got a scale here on the frequency density, and we've got a number of things missing. Our first group from 0 to 400 here, we've got a frequency, but we haven't got a bar. Our next group from 400 to 600, we've got the frequency, we haven't got the bar. But for this one, we have the bar and the frequency. So this is the one we're going to be interested in. This is the one that's going to help us. Our next one, we've got the 2 bars, but we haven't got the frequencies. Before we start any histogram question, we need to remember what frequency density being equal to frequency divided by class width. So we've got some frequencies here. Class widths are easy to work out. We can see them from looking at our groups here. So it's how big is the group, the class. This one goes from 0 to 400. So that's 400. Here is 200. 200, we're looking at the difference between the two values. 200 again, remember histogram's got different class widths. And here again, back to 400. Okay, so let's use this now to be able to calculate the frequency density. The only place we can do that here, be able to help us using the graph, is focusing on this third column to start with. So take the frequency, 10, divided by 200. 10 divided by 200 is going to give us our frequency density of 0.05. So right here, at this point, we know that the frequency density is 0.05. So now we might be able to take a look at the scale. Going back here, 1, 2, 3, 4, 5. So each big space must be equal to 0.01, which makes that 0.02, 0.03, 0.04, up to 5 here. Okay, so does that help us work out this one? We know here for our fourth row that our frequency density here is 0.04. And here for our last row, across here, halfway, you can see going here, which will be 0.15. Now we can use these to work backwards. If we've got the frequency density and we've got the class width, to find these two values here, we're going to multiply the frequency density by the class width. So our first one, we have 200 multiplied by 0.04, which gives us our frequency of 8. Then for here, frequency density 0.15 times 400 gives us our frequency density of 6. Now how is this going to help us to find our two values here when we need to plot them? Well, we need to know the frequency density. So we're going to do for our value here, frequency 8 divided by class width 400. 8 divided by 400 is 0.02. Working out our next one for here, come down this part, we've got 5 divided by 200 gives us our frequency density of 0.025. Now taking our ruler, we can plot both of those onto our graph. So our first group goes from 0 to 400 and up to 0.02. Just there. Across. And across here to complete the bar. And then here our next frequency density, which is slightly higher at 0.025, halfway along here, halfway down, 1, 2, 3, 4, 5. So coming across here, and then connecting here and here. Gives us our bar. So we can see here now that our first bar is shown here and our second bar here. So now we have a completed histogram and a completed frequency table here with our working out for class width and frequency. Here we have double brackets. And within both brackets we have surds. So just like if we had brackets before, we need to multiply each of the terms, here and here, here and here, here and here, here and here. So we're going to have 4 terms. So first we're going to take root 3 times root 3. Root 3 times root 3. Next, root 3 times root 2. So we simply put these together, root 3 times root 2. Then we take minus root 2, root 3, the negative in front here is important, and then here at the end, negative root 2 times root 2. Now we're going to simplify. Here when we have 2 surds together with the same value, they simplify just to the numerical value here. Similarly here, we have 2. In this case here, the order doesn't matter. 3's in front here, then 2, and then 2 and 3. But these are the same things. So we've got 1 positive, 1 negative. They cancel each other out. So here we have 3 negative 2, 3 take away 2, leaves us with 1. So the answer here from expanding and simplifying our double brackets with surds is simply 1. Here are 2 cones, P and Q. We're told they're mathematically similar, and we're given details around the surface area, the heights, and we're going to be looking at volumes. So before we move any further, let's have a look and recap around similarity. If a shape is similar, when we look at the lengths and we move from one to the other, we just times by the scale factor, whatever that might be, 2, 3, 4. But when we're looking at areas, and we're moving between the shapes, going from the smaller to the larger, we multiply by the scale factor squared. When we're looking at volumes in 3 dimensions, we're timesing by the scale factor cubed to the power 3. So this is going to be helpful when we look here at surface area and volume. So let's take a look at the first question. We're asked to work out the height of cone Q. We have our value here of 4. We need to find the value of Q. We do know the surface area. So P to Q. Surface area here is 24 and here is 96. So from here to here, we times by 4. The surface area of Q is 4 times bigger than the surface area of P. This is area. So if it's times 4, remember this is squared, so square root 4. So we're actually multiplying by 2 squared. So our scale factor is equal to 2, which means for our height, when we are talking about just a length, we do 4 times 2, which is 8. But when we are talking about volume, as in here we have the P, we will be timesing by the scale factor 2 to the power 3, 2 cubed. So we are timesing by 8. The volume of cone Q is 96 centimetres cubed. The next question, we have a series of algebraic expressions we need to simplify, expand and factorise. First, we expand here by multiplying the x by both terms in the brackets. X times 3 gives us 3x. Number first, letter afterwards. Minus still stays. 2x, x times x squared gives us x cubed. Secondly, we're asked to factorise completely. This means there's more than one factor. We can have a look here at the numbers first, factor of 4, and we can see that x is in both of them, so x is also outside the bracket. Open brackets, 3y, 4 times 3, 12. X is already there, we need y. Plus, 4 is already there, 1x is already there, so we need a second x. Close brackets, and we come back here to the 4x squared. Now having a look here at the simplification of our fraction. First off, we can divide here through by 4, and we get 5 at the top. We're then looking here, and we have a squared divided by a to the power 1. Subtracting, we cancel this, and we just have a. So we're left here with 5a divided by b squared. You can leave it like that, or you can bring the b up to have 5ab to the minus 2. In our next fraction, we have here at the bottom x squared minus 9. We can spot here that we have the difference of 2 squared. We have a square term and a square number. So we can split our denominator into here, x minus 3 bracket x plus 3, which means we can then cancel this and this, which leaves us with 1 over x plus 3. This question is about vectors. First, we're given a hexagon and a number of vectors shown. We're asked to find the vector AC in terms of A and B. So AC is here. To get to AC, we're going to go up A and across B. So we have A plus B. We're then told that AC, this distance here, is the same as CX, this part, and asked to prove that AB is parallel to DX. So let's first find the AB and DX. AB we know already. AB is simply A. We need to find DX. DX is this value, this vector from here, D to X. So to get there, we're going to have to go backwards on our 2b, so we'll be subtracting our 2b. Forwards on our AC, we just worked out AC, so plus A plus B. But remember, using this information, when we get here, we then have another vector, the same. Remember, CX is the same as AC, so we plus here another vector, A plus B. So simplifying here, we have minus 2b plus b plus b, that cancels, and we're left here with 2a. Now we can see here that these two vectors will be parallel because one is a multiple of the other. We can see here that 2 AB vectors is equal to dx. So here they have the same gradient as one is a multiple of the other. They both have the common part of A in their vectors. Here we have a table that shows the number of girls and boys in each year group at a secondary school. We're told that in total there are 500 boys and 500 girls. And we're given here to work out a stratified sample of 500 girls by year group. So our total we're looking at here is 1,000. And we're looking here at the sample of 50 girls. by year group. And we need to know how many for the year 8 girls. This sample size is 50, but the sample is only the girls. So we are only looking at 500 in total. Year 8 girls, there are 50. So we're taking 50 divided by 500. We are then multiplying by the sample size, which in this case is 50, to be able to find us that there are going to be 5 girls from year 8. So here we have the number of girls in year 8, the total times by the sample size, which gives us a sample of 5. We're asked to prove that the reoccurring decimal, 0.36 reoccurring, is equal to 4 over 11. There are a number of ways that you might want to do this. Let's look at the simplest way. First off, let x equal this reoccurring decimal, 0.36 reoccurring. Using that, I'm going to find 100x. This times 100, 36.36. We've shuffled along the decimal point from here along. We then have our value for x, and the key point here is lining everything up. If we subtract then, we can find that 99x is equal to, subtract, remove 0. Subtract, remove 0, 36 subtract 0 leaves us here now with a whole number 36. To find out the value of x, we're going to divide 36 divided by 99. So we have x here dividing through by 9, 4 over 11. X is equal to 4 over 11. We made x equal to 0.36 reoccurring. So this here proves that the reoccurring decimal is equal to 4 over 11. Here we're given values for u and v and asked to find the value of f. F is here, 1 divided by f, f sitting here underneath the 1. The first step is to convert these mixed numbers into improper fractions. So u is equal to 5 over 2, and v is equal here to 3 times 3, which is 9 plus 1, 10 over 3. Now we don't want u, we want the reciprocal, we want 1 over u. So 1 over u. The reciprocal of 2 over 5 is equal to 5 over 2, the reciprocal is 2 over 5. So to find the value here, the reciprocal 1 over, we flip our fraction. Similarly here, 1 over v, flip round, the reciprocal is 3 over 10. Now we have these two values to replace here and here. We can add these together. 2 over 5 plus 3 over 10. We just make these equivalent fractions, so we change this to 4 over 10 plus 3 over 10 is equal to 7 over 10. Now this equals 1 over f. We don't want 1 over f, we want the reciprocal, we want f. So f is equal to 10 over 7, or 1 3/7. Now, using the same formula, we need to make u the subject. So this part here, we need to isolate. So let's do this step by step. First off, we can remove this part by subtracting it, and it will be on the other side. So 1 over f, subtract 1 over v. Now, just like fractions, we need to make these the same, the denominators. If we had a fraction, for example, 2 over 7, take away 4 over 10, we would take our denominator here, times by 10, times by 10. Take our denominator here, times by 7, times by 7. We're going to do the same here. Your denominator here is v, so times by v, times by v. Denominator here is f, times this one by f, times this one here by f. So then we have v over fv minus f over fv. Denominators are the same, so the numerators v minus f over fv equals 1 over u. Okay, so let's find the reciprocal. So that's u. Flip our fraction here, fv divided by v minus f. And here we have rearranged this formula to make u the subject. In this question, we're shown a curve with equation y equals fx, and then told it's translated at the point 0, 0 is mapped onto 4, 0. So what's happened is the graph has gone in this direction, a horizontal shift, an x shift of plus 4. So this means that the function has changed inside here, inside the bracket, and it's the opposite. If it's shifted in this direction, a horizontal shift along the x-axis of plus 4, this is represented inside the bracket alongside the x of a negative 4. So this here is the equation of the translated curve. In our next graph, we're given here the y equals cos x, and then asked to sketch a transformed graph. We have a 3 here and a 2 next to the x inside the brackets. So first off, let's look at the 3. The 3 sitting here outside the bracket, in this part here, is going to stretch the graph in the y direction by the scale factor. So it's a stretch in the y direction, and here the y coordinates by 3. So we can see our coordinate here is 1, so we're going to times by 3, and we're going to be going up to here on 3. Similarly, we can see here the graph goes down to minus 1, so we're going to stretch it down times by 3, all the way down to minus 3. So instead of oscillating here between positive 1 and negative 1, we're going to be going from 3 all the way down to negative 3, back up to 3. That's the effect the 3 plays. Now let's look here at the 2 sitting here in front of the x. This is a stretch, but this time we're going in the y direction, and it's 1 over the value sitting here, so we're looking at a half. So we're stretching it in the x direction by a half. So if we look here, from this point, we go down here to 180. No longer we're going to go to 180, we're going to be going to half of that, which will be here 90 across. So actually, we're going to be coming down to 180 over here at this point, down here to minus 3 at the 90. Starting here, up at 3, so we're stretching up and then going half the distance down. Here we can see the peak here at 360, half of that is going to be 180, so we're going to be coming all the way up here to 180. We can see here we're just about to go down here at 540, so we're going half of that, and then coming down at this point here. So taking your pencil now, starting the curve, we're going to be coming down, try and make a nice smooth curve at this point, up here. It's not as easy on the screen to do this. Up here to 360, oh, down here. And then back up all the way up here before you get to 540. So in this question here, you need to take account of both effects of the 3 here and the 2 here.